If you'll remember, section 1.2 talked about some of the properties of real numbers. So there are some additional properties of equality that allow us to solve equations. And so the first is this reflexive property. It's just saying that something is always equal to itself. So b plus 12 is equal to b plus 12. It's this idea that things are equivalent. The second one here is the symmetric property. It means that it doesn't matter what order of or on what side of the equal sign the expression falls. So if a equals b, then b equals a. So if you look at this example, it didn't matter which side of the equal sign the 18 was on, as long as the two expressions were the same. The third one is the transitive property. That means if a is equal to b and b is equal to c, then we can kind of take out the middleman here, and a is equal to c. So if p plus 3 is equal to 48, and this expression is also equal to 48, then those two expressions have to be equal to each other. The last is the idea of substitution. And so in this case, they're substituting it out, the 6 plus 1, and replacing it with a 7. And so things that are equivalent can be replaced in the equation. So if we were going to name that property here, the first property is just showing that this thing is equal to itself. Both sides of the equal sign are the same. That is the reflexive property. What property is illustrated here? Here I've taken the x plus 4 and switched what side of the equal sign it's on. So when you switch the side of the equal sign, that's the symmetric property. A equals b is the same as b equals a, so that's symmetric. And the last here is that if 3 equals x and x equals y, then we can take out the middleman here. This can get canceled out, so 3 equals y. And that is the transitive property. What I'd like you to focus on here is not so much remembering these examples and remembering the definition of each of these things. The other properties are going to be more important for you to memorize. This is just an understanding of why and how we're able to actually solve equations. The other piece that is important is this adding and subtracting properties of equality. What this box, and the multiplication division for that matter, what this box is essentially telling you is that whatever you do to one side of the equal sign, you have to do to everything on the other side as well. That's part of the reason that we undo addition and subtraction first. If we tried to undo division, then we would, or multiplication first, we would have some additional issues. All of that may sound like a very complicated piece. These are things you've heard before, but our goal is to make sure that whatever we do to both sides of the equal sign. So there are some examples on the back of this page that we'll take a look at. So flip to example number 4. Examples 4 and 5 should be very straightforward for you. They're simply solving one-step equations. So for number 1, I'm going to add 5.48 or 5 and 48/100ths to both sides to keep this equation in balance. Doing it on the left side cancels those things out, and I'm left with m equals 5.5. To check your solution, you would simply plug it back in. So 5.5 minus 5.48 is equal to 0.02. You are welcome to chuck that in your calculator, but those two sides are equal to each other, so that answer checks. Okay, checking your solution is something you want to get in the habit of doing. You're welcome to just use a calculator for that. For number 5, we've got 18 equals 1/2 t. If I'm multiplying by a fraction, to get rid of that fraction, I multiply by the reciprocal. So I'm going to multiply both sides by 2/1 here, which is the same as 2. Here the 2's cancel and the 1's cancel, so those cancel out for just t. And 18 times 2 is going to give me 36. If I plug that back in, 36 divided by 2 is indeed 18. So that's my check. 18 equals 36 divided by 2, which is the same as 18, equals 18. Final answer. I should go back and box these in. So on a problem like this, if you're multiplying by a fraction, to move the fraction to the other side, you want to multiply by the reciprocal. Then we get into some more complicated questions here. It's important to simplify your problem down as much as possible prior to trying to solve. So for example here, I want to simplify this as much as possible. So the first step is to distribute both of these. I need to make sure that I distribute the -2 here. So I'm going to get 53 equals 3y minus 6, 3 times y, 3 times 2, minus 6y plus 2. So negative 2 times 3y gave me the negative 6y, and negative 2 times negative 1 gave me the positive 2. Then I can combine like terms here on the right side. I get 53 equals negative 3y minus 4. 3y minus 6y is negative 3y. Negative 6 plus 2 is negative 4. So I'll add 4 to both sides. I get 57 equals negative 3y. Divide both sides by a negative 3. And if I'm doing this mentally, dividing by 60 divided by 3 would have been 20. This is one less than that. So y equals negative 19 is going to be my answer. You're welcome to use a calculator for that as well. I could have done 57 divided by negative 3 in the calculator to get that same answer. But what I'm going to do with the calculator is check my answer. I'm going to say 3 times negative 19 minus 2 minus 2 times 3 times negative 19 minus 1, close the parenthesis, equals 53, which is what we thought it should be. So that's me checking my work. 53 does equal 53. Try that same process here for 6A, and then check your answer against the one that's posted on the assignments calendar. We're going to skip down and exclude example 7 and 7A, but try example 6A on your own and see if we get the same answer.